So good afternoon. My name is Tim Bailey. We're going to talk today about exploring Web3 through technology convergence. So the concept of Web3 has gained significant attention in the technology industry, but there's still no standardized definition for it. There are many interpretations, many of which are largely influenced by the cryptocurrency background in the cryptocurrency industry. So the blockchain-based service network, or BSN, aims to establish a new public layer on the internet that serves various industries and distributed applications, ultimately creating the next generation of the distributed internet. So BSN has its own understanding of Web3, which we'll talk about today. So we're going to get deeper into our perspective on what Web3 truly is, share our thoughts on the development of Web3, and help everyone better understand it. So I'm joined here by Yifan He, CEO and founder of Red Date Technology, one of the driving members behind the BSN. Yifan, so let me start off and ask you to walk us through the evolution of the internet as it's gone from Web 1 to Web 2 and going to Web 3.
I have no idea what that means. The web.
So I'm allowing you to translate some marketing speak into real technology.
So from the crypto world, okay, because why it's very confusing. You know, when people talk about Web3, Internet 3.0, Web 2, Web 3.0, it's all different things because people seeing from different perspective. You know, the Web 3.0 everybody talk about right now, actually people seeing from application layer. You know, so which means people usually say Web 1 basically is the website, you know, give you the information. Okay, like in the 90s, you know, the hardly there's if you want to communicate with the website, you just fill in a form, you know, send a text message to their server. That's it. So Web 2 become a user-generated content-driving application and website, which means like Facebook, right? You go there, most content is inputted by users. So that's Web 3. Web 2 and Web 3 means they somehow user can create a value out of the content. And then, you know, based on the cryptocurrency concept and move that value to each other. So which means, you know, people can generate value from the participants of the website or application. So that's the Web 3. So the whole thing is from a perspective of content. Personally, I definitely don't agree. Okay, because I think it's a big jump from user generates content to value. So it's I think there's no logical go there. Logically, from user generated content should jump to AI. You know, AI driving content. It's still content. Why you put a value on a content and say this is next generation of content? But I truly believe AI represents next generation of content application. Okay, so it's like the website provide content, then the user provide content, then there's an AI somewhere behind the scene, you know, study all the data it can receive and generates much deeper content to it. So it's next generation. So Web 3 should be AI driven content websites. Okay, so that's why I think, you know, it's from this perspective, the Web 3 is a marketing term from crypto world. Okay, but BSN, as we always talk about, even, you know, there's a B stands for blockchain, but we actually consider the blockchain as a communication tool. So that's actually the key. You know, when I do speech, I always use the, you know, the example, which is our, you know, the telephone example, right? It's our fundamental reason why we think this is a revolution, why we even started to build BSN 5 years ago. The example, I can repeat the example here, right? So basically, it's when the telephone invented, like 1873, at that time only two people can talk to each other through telephone, and that situation lasted almost 100 years. And in that 100 year, probably the second year, 1874, people begin to wonder why we can three of us talk to each other at the same time. It definitely makes sense much easier. So people, especially for a situation like 10 people in different location, they need to discuss something through traditional one-to-one phone calls. Just think about the process. How many phone calls you need? Someone initialize the process, call 8-9 people, each one give you feedback. You need to give the feedback to other 8 people. Everybody give you feedback again. You need to pass around. So it's hundreds, even thousands calls for 3 rounds of. And remember, when you give the feedback in different order, the result is different, right? So then after 100 years, there's some kind of technology because there's, this kind of exchange services, the internet become a thing. So with much better connection and also the computing power, people begin to build conference calls. So my question is, think about the same scenario, same matter to discuss, same 10 people, exactly 10 people. They're not smarter, not dumber, it's exact 10 people, and use 10 phones. And they all call in to a conference call and to discuss the same issue. 20 minutes, everything's done. So, I mean, what's the fundamental reason for technology is to increase productivity, right? So why from exactly same people, exactly same thing, why from one scenario to another scenario, the productivity increased 100 times, even more than 100 times. I think even probably 500 times to save money, save time, why? So that's the question, why? So the reason is the only thing changed is how data reaches people, how data moves and reach people, right? The two phone calls is always 2 by 2, then link to a network. So we call that, kind of a P2P, point to point, then connect together, become the network. And for a conference call, it's like, one broadcasting to everybody else, then everybody broadcasting back to everybody else. It's like a broadcasting, many to many kind of connection. So that means, and it's proven, everybody can understand, it's proven by this new communication with multiple parties. If there's only 2 parties, then 2 model is the same, right? But when more people joins, it sees difference. Then let's talk about the internet, okay? From a communication perspective, not a content driving perspective. So what internet is today is actually the one-on-one phone calls linking together becomes the internet. I mean, sometimes when I talk about this, some people laugh. I mean, don't laugh.
Well, it's millions and millions of those point-to-point conversations.
Yeah, point-to-point link together. So which means let's change the 10-person scenario to 10 IT systems. So even today, those 10 IT systems linked by internet, they actually call each other 2 by 2, one to one, which means for same processing, one centralized server needed to send message to non-IT system. Each IT system process it, send back, then they inform another A, then send back. Okay, it's not a human being, it's a machine, so it's faster. So, but for something to reach consensus or reach a result, it still takes probably 2 hours, right? So logically, let's changing because technology always mimic human behavior. Okay, so let's put this kind of broadcasting, 10 people also replaced with 10 IT systems. Using a broadcasting data communication, logically, it also increased the productivity of those 10 IT systems. So what blockchain is? The blockchain actually realized this communication by building an operating system, link everybody together, like the conference call. So that's why I always talk to, the non-technical people say, okay, if you really want to explain, what blockchain is, just say one sentence: enable IT systems to have conference call. That's it. That's blockchain technology.
And I think the average person understands the leap between a point-to-point telephone conversation and a conference call, because everyone has the experience of meeting a bunch of people at a restaurant to have dinner and people have conversation, right? Or a party, or meet together in a park and have conversation. They understand that. So I think that analogy makes a lot of sense to people. I think what's difficult sometimes for people to understand is, okay, in the internet example, right? I understand, I go to websites, I understand the concept of point-to-point data communication. So on the internet, if we have this broadcasting, what does that look like? What can that enable?
It's the same thing, because just think each IT system is a human being. It processes data. The data saved in the brain, in the memory, in the hard disk. It processes data, then sending to. Technology, IT system is mimic human behavior, just much faster, much quicker, much accurate. So which means, like I said, when you put 10 IT system, when one IT system sending data, is not just go to one of them, it's go to all of them. But of course, if someone receives the data, process it, then return back, it's not just go back to the centralized system, it go back to all of them. So which builds everybody actually have this joint to run a process. Then it generates a lot of benefits. For example, let me see, if their centralized system, it talk to all the people. The centralized system is shut down, everything's dead. Okay, and the centralized system, whoever in the middle can fake data, and you cannot verify to each other. No, you cannot trust each other because it's a point-to-point. But in a conference call, anyone drops, even the host drops, it doesn't affect the other people still talking, processing business, right? And nobody can lie. If you say something, everybody listen to you, and after the call, you say, oh, I didn't say that. Everybody say, okay, we can prove you said that. So that's why some people always call the blockchain network is more trustworthy, because it's everybody saying the same thing. That's why conference call is always more trustworthy than 5 people call each other one by one, right? But the blockchain technology is built for cryptocurrency, for Bitcoin. Okay, first, the Bitcoin is not for financial, this kind of security type of, financial services, because it was actually designed as a payment. But, it's really underestimate people's greedy, intention. So people kind of change that to a more speculative operation. But I always give usually play another small game. That small game basically is, okay, let's assume Bitcoin and Ethereum is a centralized system. Okay, so I usually ask, if anyone understands this, if Ethereum is centralized system controlled by one entity, what that system is. It's a very, very simple banking system. Okay, so that's why, the bank's balance sheets and individual accounts is the banking accounts, and what's the operation there, transfer money to each other. That's it. Then smart contract is banking script, transfer money in a large, a large number of transactions in a short time, triggered by banking script. Then everything is a traditional banking system. There's no innovation. The only innovation is get rid of the bank. Everybody build part of the banking system linked together through the broadcasting protocol. Then it becomes very innovative because everybody can come in, open bank account without bank. Everybody can initial transfer money. Then immediately people begin to build a different application, different scenarios. Makes a lot of sense. The bank, centralized bank cannot do, become available. So that's why entire blockchain industry, entire crypto industry build because just one thing, the better communication protocol. Okay, just imagine if it takes 3 months to reach consensus for all the validator node of Ethereum doesn't exist anymore because the pricing cannot sync to each other, everybody cannot verify to each other, then it's a crash. It basically crash. So that's why I want to emphasize is everything make blockchain become blockchain, cryptocurrency become cryptocurrency, just one thing. Now, because the internet involved and the computing power involved into a stage to enable conference call for IT systems. So then my next question is, cryptocurrency needs consensus. That's a very specific business scenario. Just like, okay, let's 5 of us, let's have conference call, always reach agreement. If you don't reach agreement, don't use conference call. That's a very specific. Sometimes we just have conference call to have fun and to argue with each other. We don't need to reach. So which means besides the blockchain, besides the cryptocurrency, there are so many things you can do in a much more efficient way through a multi-party system, right? So this is the concept that we sometimes call that public IT system compared to the private IT system. Sometimes we also use the multi-party IT system compared to single-party IT system, right? Single-party IT system, you can shut down, everything's gone. Multi-party system, if you shut down yours, other people still, go through the, like the conference. You drop out, it doesn't affect other people doing business, right?
Right. So I think that's one key benefit is you talked about is the redundancy, right? There's no single point of failure, right?
Yeah.
Going back,
transparent. Sure. Because everybody can see what other people is doing, what's their reaction. Because in a multi-party system, the most important thing is I think 2 or 3 features. The first one is everybody have single rights, same rights to the input and output of the data, the processing, the data from the process. Then the next one is anyone drop out doesn't affect other people, because if someone drop out, the whole conference call closed, then this guy has much better power than other people. It's a single party system. So that's basically how you define it. Like if you are a validator node on Ethereum, if you take down your validator node, Ethereum doesn't affect anything. Just one validator node less. So that's then you can do a lot of things in a much efficient way than the traditional internet. See, now I use the word traditional internet, which means we believe this kind of multi-party system should form next generation of internet. So in my definition, from a communication and a connectivity perspective, the traditional internet should be the internet 1.0. Let's put this, let's also use 1, 2, 3. The original intranet, the university built in the 60s, 70s, let's call that Web 1.0. And the internet today we see it should be the internet 2.0. And the internet supports both multi-party system and the single-party system should be the Internet 3.0 or Web 3.0 from a communication and the connectivity perspective, not content perspective.
Hmm. So let's talk a little more about what BSN is doing specifically in order to help enable that and make that happen and push it forward. Can you talk a bit about that?
Okay, so let me still use the Internet or Web 2.0 in our definition, the traditional
Yes.
Internet. First, we need to understand what's the layer on the traditional Internet, right? There's a physical lines, the fiber optics, right, and the big servers. Remember, Internet is for communication only. The data storage and the processing and the computing with the machines. So remember, Internet doesn't store data or processing data. It moves data, but once the data in the machines, in the servers, in the phones, in the computers, it computes and stores data. Okay, understand? So the first layer should be the physical layer with the physical lines and the machines. That forms the physical layer of the Internet. Then what's on top of that? It's the clouds. It's the clouds. No matter it's just one single machine or big machine like AWS. So it's a cloud environment. And for example, your phone actually is a small cloud. It's a very small cloud, right? Other people can access to your phone, then your phone is a cloud. Inside the cloud, you need to install operating system, right? It's on AWS, you go there, you need to install Linux. On your phone is Android and iOS. Then each operating system need to install into an instance, right? Then on top of the operating system, you install your application. Like on your phone, you have so many applications in one operating system. So that should be the layer of the traditional Internet. Physical lines, cloud, operating system, plus instance. Then on top of that, there's database applications layer. So on each, there's a website. We still need it because no matter your phone, each application is a website. And on each website, there's many business scenarios, right? For example, you go to Amazon, you can buy stuff, you can watch TV, you can do a lot of things. So the layer, right? On the next generation of Internet, first, the physical line is still there. There's no way we can rebuild the physical layer. Okay. But remember, it's no longer one instance. For multi-party system, it's many instances linked together to become one environment. For example, for Ethereum, it's many nodes linked together. Each node is an operating system in an instance. It's a little bit technical, okay? But my logical is, for this kind of multi-system, there won't be like in entire country, there's just one blockchain or one multi-party network. Okay, it's like today we say, this country's Internet is one website. You go to the website, do everything. It's impossible. So which means, remember, in the world, this kind of like the blockchain environment today, which is very premature, okay, there will be millions, even billions of networks to link like two-party, three-party, or unlimited party to process all kind of data, operations, application, everything. So the layer here is a physical layer, cloud, because it handles multiple instances, sync them together, the cloud is different. Then the operating system is different too, because it handles multi-party application. Then there's the instance. Then on the instance, there's multi-party environment like the websites. There will be many websites. There will be many networks. On each website and on each network, there's many applications. So that should be the whole stack. So that's why there's a big concept, which blockchain industries, when you only think some very specific scenario, like a cryptocurrency, you say, oh, I only need those three chains. Yeah, it's same thing. I mean, in the traditional website, you say, oh, I want to buy some book. How many websites there? Three major ones count for 99% of the market. That's it. But remember, there's so many business scenarios other than selling books. That's why there's so many websites. So that's why if you think outside the crypto world, the blockchain world, there will be so many networks to handle different data operations. So remember how many websites we have on the Web 2, we will have same number of networks on Web 3. Then you need a very powerful operating system, which no blockchain protocol can support today. And then you need a very powerful cloud infrastructure, because right now all the cloud handles single party system. One instance, install one operating system, install your application. Then here the cloud needed to handle multi-party instance and systems. Link probably handles one network. It link millions of, instance. Some is on personal phone, some on AWS, some on Google, some on someone's laptop. You need to link all of them together. How you even do that? And the BSN is handling the cloud layer. Okay, that's what we do. So we are not a blockchain technology company. We are cloud technology, next generation cloud technology. And what's our relationship with blockchain? Blockchain we consider is an early version of operating system to handle multi-party systems. So it's like Linux in AWS. So what we do is like a decentralized AWS kind of technology. Then the blockchain protocols link back like the Linux version, different version of Linux. Then each blockchain is like each website. Then on the website, each application like a small smart contract on the blockchain. So that's the whole stack. So that's where BSN is. We try to build next generation of cloud software. So because in a long-term view, in 10 years, in 15 years, all the physical data center need to support both single-party system and multi-party system. They need two cloud infrastructure, at least one cloud infrastructure able to support both scenarios. So we are trying to build that. So we're basically building the technology for the future. Okay, nobody really understands today or cares today. So that's why we need to shoot this video to explain.
So Yifan, going back to the analogy of the traditional internet, right? I remember in the early days of the internet, like the first things that I personally used that I thought were interesting were email. Right? I was like, oh, I could sit at my keyboard, I could type something, and then my brother at university, 5,000 kilometers away, he could get it like instantly and read it. Right? I didn't have to write a letter, put it in an envelope, go buy a stamp, put it in the mail. It gets there 1 week later. So there was email. I remember that was really interesting. I remember I could go check if I wanted to book a travel. I could go check the prices of the plane tickets at different airlines. Right? I could compare, and I didn't need to call a travel agent. Right? And then the third one that I remember being really interesting is suddenly you could find other people who are interested in the same subject that you were interested in, whether it was collecting stamps or reading fantasy novels or playing Atari video games or something. You could very quickly find that group of people, whereas in the real world, you walk around on the street, it's hard to find people who are interested in the stuff you're interested in. Those for me were kind of the early things were interesting, and then eventually there was e-commerce and a bunch of other things, right? So if I go back to that, we're kind of in that stage right now, like the early 90s stage, right? So
Yeah, I totally understand what you mean. We are not in that stage yet. We are not.
We're before that.
Yeah, I consider this is should be internet 1985, not even 85, like 84 or 83. Remember, today when we talk about internet, everybody understands.
Mhm.
It took people 40 years to even begin to understand what internet is. That's how long it will take us to explain. Okay.
Mm. But so if I
So
so again, yeah,
yeah,
we can agree or disagree about the exact timing. But if I go back to those three examples, right, I think one of the things as they understand, okay, multi-party systems and conference calling between IT systems, like can you give like one or two examples of what you think will be those early
yeah,
things?
yeah,
Like what's going
yeah.
to be the version of
Uh,
email? What's going to
no,
be the version of what is that? What's that
I
the
know.
first kind of mass market thing people get to
Okay.
touch?
Okay. When we explain what we do now, actually using the existing internet example, because all technology involved the same way, right?
Hmm.
Why I say now it's like early 1980, because I remember in 1985 or 1984, TCP/IP becomes the worldwide standard. Before that, all the intranet using their own protocol. They cannot even talk to each other. When all the intranet cannot talk to each other, there's no internet.
Hmm.
So by then, and what's today's blockchain industry? Nobody can talk to each other yet.
Hmm.
So it's before 1984. Okay. So, but remember, the internet concept as the first network was built in the late 1960s.
Hmm.
So even for 1984, it's almost 15 years later.
Hmm.
People begin. So see, now almost 15 years since Bitcoin. So
Hmm.
people begin to talk interoperability. It's an old concept. It's so old. Like, people need a translator to translate different languages 2000 years ago. That's called the
Hmm.
interoperability. Okay. So
Hmm.
that's why I said, but what you just asked is a very important point, which means you need a human-like application for people to understand, to boost understanding the whole internet infrastructure, right? You mentioned it. Basically, it's two applications, email and the web page.
Hmm.
So from a communication point of view, those are the two types of communication. Email is I sending my data to you, right? Email, right? And the web page is I go your place to fetch the data to me. This is actually two-way communication. That's why it's the most simple one. So, but I first used the email in 1996. When I first used that, I received my first email in my whole life. I was shocked to almost to death because the reaction is this going to change the whole all human world. Okay. My same feeling when I figure out the blockchain is a communication, new way of communication. So that was the same feeling. But the same thing people will see after 15 years of since Bitcoin, I think it's email is very early. Email in 70s, right? In the intranet, people can send email. But after 1954, people can send in email across intranet because they adopting the same protocol. Website was realized in 1992 when the browser became a thing, right? Then you can use a tool to get data from other server to your computer. So, say that it's 15 years and another one is almost 23 years. Then those two fundamental application emerges, begin to boost the awareness of the internet. So then the next question is, okay, what's the fundamental application for the new internet? Actually, pretty clear. Everybody talk about them right now. One is central bank digital currency. okay, digital money, because the central bank digital currency, when it's out, it will speed up the efficiency of money circulation, and ownership of the money. It's a big jump for the financial services, traditional financial. So I think it will become a thing, even not now, but I think in 3 to 5 years, it will become very popular. Okay. And then the second thing is DID. Everybody talk about DID, right? Everybody talk about that. The DID changed because right now when you go to a website, do whatever, you need to store your data somewhere in a centralized server. Then you can, you go there, they can check who you are, then, then you have to store your data. That's how internet single party system built. But with DID, then you can actually control your own data. You only give them a DID. Then everybody can process the DID, which you control in a public network and the environment. Then everybody need to come to your DID to verify who you are, and you give them permission. So those two things I consider the websites and the emails of the new internet, because those two things is very fundamental. Any system need to move money, you need to use central bank digital currency. Everybody want to, give their user more control of their own data, more privacy. Then you need to adopting this DID system. Then those two actually will slowly make the traditional Web2 operators to understand the benefits of the next generation of internet. Then slowly people begin to understand, and there's more and more application built with this kind of multi-party IT architecture. Then more and more use cases you will see. So personally, I think, if you ask me, I see in 15 years, probably 20 to 30 data transaction, data movements should be on the new layer of the internet. So yeah, I think that's a very big market. That's a very big market because we don't have anything yet. We don't have a cloud infrastructure. We don't have a better operating system. We don't have decentralized database technology. We don't have any application. So basically, there's so many opportunities out there in the next 10 years.
So what? Those are great examples, and I think of those really like fundamental applications or utilities that can be used to enable thousands of different scenarios, right? What other tech? We talked a little bit about blockchain technology being very primitive at this stage, and it will evolve, and we think of it as an operating system. What other technologies do you think are important or essential? You talked about AI a little bit. Maybe you can talk more about AI and other technologies, and similar to you thinking that blockchain needs to evolve. How should some of those other technologies evolve, and why are they important?
Okay, because I'm still in the communication industry. Okay, so AI is processing data, so we are totally in different world. But when I talk to anyone working in blockchain, I say blockchain technology is so premature, it's bad, it's not usable. Everybody, not one single people believes me. And then I remember when I first time use computer, it was like I was like 5 years old or 6 years ago. That was DOS system. Right? There was no Windows. Okay, there's no user interface. It's a DOS.
Yeah, most people watching this are not going to know what you're talking about.
Yeah, DOS is So at that time, trust me, everybody think DOS is the most advanced operating system in the world. And when someone said, "Oh, no, you don't need DOS. There will be much better system. People can click around, move things visually, beautiful." And then nobody say, "Yeah, I have no idea what you talk about." So all the IT is evolved from early stage, slowly become better, become more efficient. That's a way. Let's say blockchain technology is basically serving cryptocurrency. How many data can be operated and stored in a ledger? accept the financial data, or we call balance-based data. Balance-based data. I mean, it's because for the new multi-party, we need to process any business scenario, any data scenario. How can even blockchain handle it? I mean, a program called smart contract, it's like 500 lines. We don't even call that program. We call that script. You need 500,000 lines to be called well-built systems. With different class, with different package. You call. It's. So in order to make the multi-party architecture more powerful, you need more powerful operating systems. Like you need to involve from DOS to Windows, then to Windows NT, okay, as a server level. Then so which means the blockchain as an operating system, we should evolve to support more data formats, data operations, the programming language, and runtime environments. Then the next thing we're also missing, database. On internet now, database is a ledger. On the blockchain is a ledger. Like I said, it's a ledger. Think about how big Oracle is. and this is a small ledger. So, but Oracle is a single party system, right? Even they give you multiple access, everybody, but someone can shut down the Oracle by one single party. So you need to build this kind of more sophisticated relation, database technology with multi-party control. Right. There's a lot of things. The database technology, the operating system are the most important fundamental technology. Think about how many applications you can build with DOS. Right. I mean, game can be built. In early 90s, I played a game called MUD, M-U-D. I think as a most kid, it's text-based. Text-based, you have text, type text. So it's a but how can you even build a visual game with DOS system? Right. But the Windows is not on Windows. It also involves hardware, the video cards, the sound, the different resolution. It's everything need to involve. So for this multi-party application internet, next generation internet, even hardware needed to involve to support that kind of computing power. Everything. That's why I say there's huge opportunity in next 10 years because everything needs to be upgraded from hardware, from networking, even the physical line. You probably can build some, thing to make that even better, to connect to other parties, right? Then the hardware, the operating system, the database, the cloud, almost everything today. That's what we need to be done. And we actually, if you're really looking back, after 10 years, BSN actually started in real sense. Okay, many people started blockchain, cryptocurrency without a clean sense, but we have a clean sense where we want to go. We start building in 2018, 5 years ago. Okay, so we already spent 5 years investment and the time on this one. We probably need to spend, but we see light. We see, since this central bank digital currency become almost irreversible, right? DID becomes so popular, even traditional business begin to adopting them. So and we are going to launch China's national real name DID system in 1 week. Okay, everybody will see the news. So it's coming. After 5 years, we see this is much faster than I thought. So this is huge opportunity. I mean, today's video, one thing I want to emphasize is there are huge opportunity. We need more startups, entrepreneurs, to join us, to seize the opportunity. Because the big corporation, it will be very slow for them to make such dramatic change in their the technology stacks. It's opportunity for startups and entrepreneurs. Okay, join.
So Yeah, so if I was going to ask you if like you say, sometimes big companies they can move very slowly because they're focused on today's business, right? And the profits today. They're not necessarily looking out into the future 3, 5, 7 years. If if there were a student or an entrepreneur or a startup today that was, interested in pursuing this and how they can support it, what would you want them to do?
First, learn technology. Okay, I think now the technology becomes so advanced in past 20 years. For any, good business people or good government people, they truly need to understand technology to have a broader thinking, logic. So learn, no matter you want to focus on the pure technology or business or governments or, almost everything, you need to understand basic technology. So study something like math or physics or even computer science, to start at least. You don't need to do the work in the future, but you need to understand the logic behind all technology. And if you are really interested in this, you can start with blockchain, but always thinking in a broader sense. Don't be cornered into cryptocurrency. Everything is cryptocurrency. So have much better, but understand from a fundamental way. Just like today, our video shows from communication and how many things you can build from the bottom. The logical needed from the communication layer, then up. Then you will see so many opportunities, so many possibilities beyond your imagination. But you need to understand basic technology first. This is, 20 years ago, I don't really say this to, friends who ask me, where I send my son to study. I say, well, accounting probably better, But today is learn technology in undergraduate. Okay, then business, everything else in master or PhD. But if you don't understand technology today, you won't be a best business guy. You won't be a best government official. You won't be, anything. You need to understand technology.
Okay, great. Well, Yifan, thank you. Thank you for your thoughts today. It's exciting to hear about the future, and I think one of the most important takeaways that I would have is you're talking about the two kind of trends that you're seeing. One in central bank digital currencies and digital payments, and then the second in DID or decentralized ID. And I think those are certainly areas that we need to watch over the next year. Thank you. And thanks everyone for joining today.
Thank you, Tim.